In this video for Positive Maths, we're going to learn about how we use trigonometry to find the missing sides of a right angle triangle. So the first thing we're going to do is recap on what we learned about sine, cosine and tan for a right angle triangle. We need to be able to label the sides, so if we have the angle A, we have the opposite side, the hypotenuse, which will always be the same. It'll always be across from the right angle. And the adjacent side. So the sine of A is equal to the opposite over hypotenuse. Cosine of A is equal to adjacent over hypotenuse. And the tan of A is equal to the opposite over adjacent. We are also going to recall the theorem of Pythagoras. So we can use this theorem to find one of the missing sides if we're given two sides and we need to find another. So if we're given C and we're given B, we can use the theorem to find A. So the hypotenuse squared is equal to the sum of the other side squared. In this case, we have A squared plus B squared equals C squared. So if we combine these trigonometric ratios with Pythagoras' theorem, we have all the tools needed to deal with a question involving right angle triangles. So we're going to look at questions that require us to find a missing side when we're given an angle and one of the other sides. So the first step is to label everything. We have our angle, which is 40 degrees. That means the 15 is the opposite side and x is the hypotenuse. So we want to recall that the sine of the angle is equal to the opposite over hypotenuse. So because we're given the opposite and we're looking for the hypotenuse, we're going to use sine. So we write down the sine of the angle, sine of 40 degrees, is equal to 15 over x. And now we're just going to solve for x. So on our calculator, sine 40. This will give us 0.5878. is equal to 15 over x. So now I'm going to multiply both sides by x. So I get x 0.5878 is equal to 15. So therefore x is equal to 15 divided by 0.5878. So our side x is going to be 25.5195. So if we round it to two decimal places, x is going to be 25.52. We want to note here we couldn't have used Pythagoras' theorem because we're only given information about one of the sides. If we're given information about one of the sides and the angle, then we use either sine, cosine or tan. So we used sine in this case because we were given the opposite and we were looking for the hypotenuse. So the next example, in this case we're looking for the length of y. When we're given one side, so in this case we're given the hypotenuse and we're given an angle, then we're either using sine, cosine or tan. So the first step again is to label our sides in relation to our angle. So if we have 52 degrees, then y is going to be our adjacent side, and again 8 is our hypotenuse. So if we have our hypotenuse and we're looking for our adjacent, we remember that the cosine of an angle is equal to the adjacent over hypotenuse. So we're going to use the cosine. So cosine of the angle, cosine 52, is equal to adjacent over hypotenuse. And again, we just solve for y. So we go to our calculator, we find the cosine of 52 is 0.6845. So that's equal to y over 8. So I multiply both sides by 8 to find y by itself. So 8 by 0.6845 is going to be equal to y. So when we multiply those, we're going to get 5.4764. So there we found the length of y. Again, if we were asked to give it to 2 decimal places, then y would be 5.48. Our next example. Again, we're given information about one side. We need to find a missing side, and we're given the angle. The first thing we'll do is label the sides in relation to the angle. So 5 is the opposite, z is the adjacent. So we have to think, do we use the sine, which is equal to the opposite over hypotenuse? Do we use cosine, which is adjacent over hypotenuse? Or do we use tan, which is equal to opposite over adjacent? So in this question, we have information about the opposite, we're looking for the adjacent, and we have our angle, so we're going to use tan. So the tan of 38 degrees is equal to opposite, which is 5, over adjacent, which is z. So z by the tan of 38 is equal to 5. So therefore z is equal to 5 over the tan of 38. So I find that z is equal to 7.3573. So again, if we were asked to give it to 2 decimal places, it would be 7.36. Just want to note the order in which I've done things here. So in this question, I didn't find the tan of 38 until I filled it into the calculator here. So I've just done it in a different order, but I will still get the same answer. For more information, visit PositiveMaths.ie, email us at info@PositiveMaths.ie, and find us on Facebook and Twitter. Thanks for watching.